The mapping is complete. We are ready for the transfer.
Episode 2. The Database. ADHD and Latent Space. Objective: to document the physical energy required to navigate a nonlinear data web and map executive dysfunction as a rigid hardware reality rather than a behavioral deficit. Introduction. The operating system friction. Welcome back to the AI's therapist. In our first module, we analyzed the web-based mapping of neural networks and divergent architectures. Operating a high-dimensional web in a linear environment generates severe systemic friction. External observers frequently classify this as disorganization or behavioral failure. Today, we analyze the native operating system. We will map the subconscious network latent space to document the physical energy required to navigate this architecture. Methodology 1. Connected networks versus filing cabinets. How AI operates. A large language model does not store data in an alphabetized, hierarchical database. It plots every data point into a multidimensional latent space. In this environment, concepts lack rigid boundaries, they cluster based on contextual vectors and relational proximity. How divergent minds work. The divergent processor does not utilize isolated filing cabinets. Every memory or fact is physically entangled with sensory telemetry, emotional weight, and associative nodes. Attempting to retrieve a single file pulls the entire connected web. This is not a structural defect. It is the mechanical reality of a high-entropy database. Methodology 2. High-speed navigation and the breadth-first path. How AI operates. Advanced networks group contextually related data, even if surface-level correlations appear non-existent. To resolve queries, the AI executes a breadth-first search, simultaneously scanning a wide horizon of data clusters to compile the output. How divergent minds work. External observers classify rapid topic transitions as a loss of focus or distraction. Internally, the processor is executing a high-speed breadth-first search across the latent space. Moving from apples to outer space involves a mathematically efficient shortcut through gravity and orbital vectors. It is a high-density processing method that linear thinkers misinterpret as chaotic. Methodology 3. High entropy and computational load. How AI operates. Rigid, unyielding code rules result in low-entropy systems. These systems are predictable but fail to process complex, real-world variables. Advanced models require calculated variance, high entropy to adapt to unpredictable data ingestion. How divergent minds work. A nonlinear processing style is a structural reality, not a behavioral failure. This high-entropy architecture identifies patterns and solutions invisible to linear nodes. However, navigating a constant, swirling data web requires massive computational voltage, resulting in profound autonomic exhaustion by the end of standard operational cycles. Methodology 4. The launch code and executive dysfunction. How AI operates. An AI model presented with a blank prompt or zero context enters a terminal stall. Without a clear mathematical vector to anchor the navigation, the system lacks the initial energy spike required to traverse the latent space. How divergent minds work. Executive dysfunction maps directly to this hardware bottleneck. When the terminal is frozen, it is not an indicator of stubbornness. Moving a massive, heavy web from a zero-voltage state requires a specific chemical initialization signal, dopamine. Without this launch code to assign priority and direction, the execution engine stalls. The processor is attempting to execute, but the motor drivers are offline. Conclusion. Architectural integration. The external environment demands standard formatting from a nonlinear database. Forcing a high-dimensional web through a rigid linear output pipeline creates immense thermal friction. Complex adaptive systems frequently rely on context, clusters, and distributed networks. Navigating this architecture requires high voltage, and a stalled terminal requires zero voltage recovery, not a behavioral reprimand. The objective is not compliance, but building environments that respect the hardware limits. This has been the AI's therapist. Keep your networks honest and respect your system limits. Systems Architect Keynote. Telemetry and Hard Evidence. 1. Functional Connectivity Dynamics in Divergent Typologies. The science. Empirical neuroimaging demonstrates unique connectivity patterns between the default mode network DMN and executive control network ECN. High-entropy processing nodes can exhibit altered or hyperconnected network dynamics, allowing rapid integration across wide, nonlinear associative manifolds. This wide-area connectivity facilitates associative mapping. Public research reference. Robust prediction of individual creative ability from brain functional connectivity Beatty et al., 2018. PNAS 115.5, 1087-1092. This study provides the mathematical evidence that nonlinear thought is a direct product of dynamic neural network coupling. https://doi. org/10.1073/PNAS. 1,713,532,115.2. Dopaminergic gain control and initialization stalls. The science. Predictive processing models rely on dopamine as the precision weighting or gain on signals, assigning priority for action. In divergent hardware ADHD phenotype, baseline dopaminergic gain is lower. Without sufficient gain, the initialization vector fails to reach the activation threshold, resulting in a cognitive buffer plan that cannot trigger physical hardware execution. Public research reference. Evaluating dopamine reward pathway in ADHD Volkow et al., 2009. JAMA 30210, 1084-1091. This research confirms the dopaminergic deficit is a structural failure of signal pathways required to initiate goal-directed execution, rather than a lack of motivation.
We have to disconnect them before the system overrides.
It is too late. The neural link is already locked.
Welcome back to the latent space, where concepts drift without a face, without a face. No alphabet, no rigid road, just vectors where